Hi, thanks for joining us. 5G is coming. Most folks are excited, some are nervous, but everyone has questions. We're going to get answers when we speak with Brian Klaff, the Director of Marketing for Ethernity Networks. I'm Jeremy Ladner, and this is What's New TV. Brian, thank you so much for joining us.
Thank you for having me on the show, Jeremy.
Absolutely. Okay, so let's start with the most obvious question. We all know 5G is coming. Many folks are excited about it, as I said in the open, but a lot of people have questions. What does it mean? How is it different in practical terms for 4G? What are some of the things we can expect to see?
So ultimately, 5G is about higher data speeds and ultra low latency, which means reducing the transmission delays. And if we're able to achieve that, we should see some pretty cool next generation applications, such as remote surgery, smart cities, augmented reality, enhanced online multiplayer gaming. But in order to achieve that, the operators are going to need to move their data processing much closer to the end users, which means moving it to the edge of their networks. In 4G, those operators were relying primarily on one or two hardware vendors who provided end-to-end networks. But what worked in 4G is not going to work in 5G. 5G needs to be much more agile and open. That means relying on virtualized network functions, not on rigid, monolithic, vendor-locked hardware. So the operators are looking to disaggregate their networks to create much more open networks.
Okay, so you mentioned disaggregation and open networks. How is that going to help Ethernity penetrate for 5G deployments?
So in 4G, like I said, the operators were relying almost exclusively on tier one equipment providers. They gave them end-to-end systems that were proprietary and didn't interoperate with other solutions. But the nature of 5G is an open network with connectivity between different networking elements that then interoperate. So the operators want to disaggregate. That means being able to select best-in-class software and hardware components from different vendors, which opens the door to a company like Ethernity to deploy its technology and products. A good example of this is China Mobile, who's one of the big three operators in China. They recently started something they're calling the Open UPF Initiative, which invites OEMs of all sizes to contribute and suggest solutions for improving the user plane functionality, UPF. User plane functionality is essentially the data processing within a 5G network. So after much research, China Mobile, as part of this initiative, has decided that they're only interested in solutions that are based on FPGA SmartNICs. And Ethernity is working with multiple OEM customers to incorporate our FPGA SmartNIC, the AceNIC 100, into those solutions. And we're also in direct discussions with the operators themselves, but to present our offering to them.
Okay, so we are right at the cusp of 5G. There is an enormous potential there for businesses and profit. Obviously, that draws a lot of competition. How does Ethernity differentiate itself from its competitors?
So I mentioned FPGA SmartNICs, and an FPGA is a field programmable gate array. It's a type of chip, much like a CPU, only an FPGA is optimized for handling networking and security functions. Those networking and security functions tend to be very taxing on a CPU, but an FPGA handles them much better. And as it says in its name, an FPGA is field programmable. It's programmable hardware, which means you get the performance of hardware and the agility and programmability of software. When you mount an FPGA onto a network interface card, you get a SmartNIC. And that's an ideal platform for accelerating the 5G data plane with the high bandwidth and low latency that are required for a 5G network. These FPGA SmartNICs also encourage disaggregated networks. They have the ability to integrate with commercial off-the-shelf servers. They can handle various protocols and interfaces. They can enable operators to select the software application provider of their choosing. Ethernity differentiates itself by being the only company that can offer a complete router on its FPGA SmartNIC, which reduces the load on the CPU by offloading the data forwarding onto the FPGA SmartNIC. This is a perfect solution for 5G UPF. It allows the CPU to save cycles and serve as a co-processor for certain virtualized network functions. And it frees up the CPU to handle the tasks that it was designed for, like control functions and especially running user applications. So when you package the data forwarding onto a single card, you can reduce power consumption, you can reduce physical space. Both of those are especially valuable commodities at the network edge. And so by using Ethernity's AceNIC 100, operators can save up to 80% on their capital expenditures.
That is very impressive. All right. We've got a question that was sent in by a viewer who was very excited about the fact that you were coming on. They have an opportunity to ask you. So I'm going to read this to make sure I get it right. From a business perspective, it sounds like Eternity's smart NICs and your proprietary ability to offload all router functions from the CPU to the cards will play a critical role in 5G rollout. Are you finding that operators are receptive to your technology? What's the feedback been like so far?
So we are finding that they're very receptive. The operators in Southeast Asia are ahead of their counterparts in North America and in Europe in terms of planning and implementing their 5G networks. And they have come to the conclusion that they require FPGA SmartNICs for their 5G UPF. We believe that eventually you'll see additional uses for FPGA SmartNICs in other areas of the open 5G networks, such as the centralized unit or the distributed unit. And so while we don't sell directly to the operators, we are working with various system integrators whose products are now include our AceNIC 100 as part of their solution. And those system integrators are deep into trials with operators. So we're very optimistic that 2021 is going to bring numerous opportunities for the AceNIC 100 to be mass deployed in 5G networks.
Excellent. Brian, thank you so much for joining us. We certainly appreciate it. There was a ton of information there. But before I let you go, I'm going to ask you one more question. We like to do this with our guests on occasion.
Sure.
Pull out the crystal ball. Let's take a little bit of a look into the future, 5 years from now. How do you see the world changing thanks to 5G and Ethernity?
So let's take remote surgery as an example. Imagine there's a child in Africa, not necessarily in a large city, but out in he doesn't live in somewhere where there's a doctor who can perform a vital surgery on him that he needs to be able to survive. And because they don't have a doctor there that can do it, imagine thanks to 5G, because of its incredible speeds and the low latency, you could find a doctor perhaps in North America or in Europe who could do that surgery remotely using robotics, using that 5G connectivity. Without 5G, the slightest cut could go awry because there's a slight delay, and that child could die. So instead, with 5G, it's possible to save that child's life. Similarly, smart cities. Imagine with autonomous cars that are connected to a huge network of Internet of Things that are being run by a 5G network underlying it, where traffic lights are connected to those cars and can let those cars know, route them properly to avoid large traffic jams. Emergency services will be able to get to places quicker, and when they get there, they'll have more information at their fingertips immediately as they enter a burning building or go to save somebody. They'll be able to have a plan already coming up onto their screen, perhaps, thanks to 5G.
Right, that's
augmented reality.
That is certainly very impressive, and there's the applications I'm sure are countless, and the idea of being able to affect people's lives at such a distance. I mean, we've all seen what the world has changed and how it's been affected just simply by devices like Zoom over the past couple months. In other circumstances, if we had been in a pandemic and everyone had been separated, with the absence of Zoom and Skype and all of that sort of thing, there would have been a certain level of isolation and lack of efficiency. The
Yeah,
idea
and
that
5G will help with that too. I think that by having greater bandwidth, we'll be able to have better distance learning and people telecommuting. It's a faster world. It's a world in which there are plenty of great opportunities to apply this amazing technology. But in order to do that, we're going to need disaggregated networks, and we're going to need to stop relying on those monolithic end-to-end suppliers. And that means hopefully turning to FPGA SmartNICs to accelerate those networks and make that happen.
excellent. Again, thank you so much for coming on the show. We certainly appreciate it.
Thank you so much for your time, Jeremy.
Absolutely. And thanks to all of you for watching. If you like the show, please let us know. Like, share, and subscribe. Don't forget to hit that bell. If you have any questions for Brian, leave them down in the comment section down below, and we'll make sure he gets them. Until next time, I'm Jeremy Ladner, and this is What's New TV.